Hello and welcome to my YouTube channel Electrical Hub. Here we are going to discuss about the generator protection. This is the first part of the generator protection. Here we are going to discuss about dead machine protection or accidental energization protection. It means that during the shutdown period or during the startup period, if the generator breaker is accidentally energized, then what are the protections of the relay to trip the breaker? We will discuss about it. I would like to request you to please like, share, and subscribe my YouTube channel because here we are going to discuss a lot about the electrical ideas, and I hope it will be better for your friends too. What will happen if the breaker is energized? Then the generator will start behaving like an induction motor. Why? Because of the supply voltage at the stator side, a magnetic flux will be formed, which will try to move the rotor as it happens in the induction motor. And since the rotor is at the standstill condition and there will be a rotating magnetic flux of the stator, as it happens in the motor, it will move with a very high slip. So the current will also be very high. It will damage the rotor winding. Let us consider a simple SLD to understand the dead machine protection. Here is one generator transformer, breaker, the grid supply, tie breakers, and some utility supply. These tie breakers are closed when there is a shutdown and open during the running period. Now, let's consider that there is a grid supply. So, I have just marked with the dotted lines to understand where there will be the power when there is supply from the grid. So during the grid supply, there will be a transform a power at the breaker, near the breaker, station transformer, the tie breakers will be closed, and the utility breaker outgoing areas. So if someone will energize the GT breaker or the grid breaker, then there can be a chance of going power to the generator. Or since the tiebreaker is in the closed condition, so someone if accidentally energize the utility breaker and if there is a common breaker, then the supply can go to the generator. So this can happen accidentally. If such an accident or incident happen, then the machine will protect itself. Due to that, there is a protection known as the dead machine protection. We will explain how it will protect itself from the tripping. Sorry, damage. So this is the path shown of the current flowing during the shutdown period. So there are two chances of accidental energization of generator is if the breaker is closed or the utility and a common breaker for the utility is closed. As I have shown in the drawing that this protection is of three criteria. See here, one is the overcurrent and the other criteria is under voltage, under frequency or GT breaker open. Here the condition number one will be if overcurrent and under voltage. Second, if overcurrent plus under frequency. And third is a very interesting one. It is to protect the protection. We will explain it later. That is overcurrent plus GT breaker open. So if under voltage, under frequency, and GT breaker open, any of this is healthy, that is, the signal 1 will go here, and the overcurrent should be healthy. If these both are healthy, then due to the AND gate, it will trip the breaker. So, in OR gate, under voltage, under frequency, or GT breaker open, any one should be healthy and the overcurrent should be healthy. If these two conditions are healthy, then it will trip the GT breaker. What will happen if the GT breaker is closed and accidental energization happen? Then the generator will start behaving like an induction motor. It will draw very high current from the grid because of the high slip, as the heavy rotor is in the stationary condition and the rotating magnetic flux will try to move the rotor. In this case, the windings may get damaged. So to protect the equipment, the overcurrent plus under voltage protection will get enabled. How? The overcurrent will happen because it will draw high current due to the high slip, and at the same time in the side of the generator there is a CT and a PT. PT will sense the under voltage. So when these two conditions, overcurrent plus under voltage, will become healthy, it will trip the generator breaker. During the startup, Let us imagine a situation where the generator voltage is reached, but the frequency has not in accordance with the grid. For example, the frequency is still 47.5, the tripping value. So what will happen as soon as the generator breaker will be closed accidentally, the PT will sense an under frequency and the higher current will be drawn. Due to this condition, the generator may get damaged. So it will trip the breaker at the overcurrent or under frequency condition. The third and the final is overcurrent plus GT breaker open condition. It is actually to protect the protections, means it will not trip the breaker. This is the situation when you have already put on the excitation, you have reached the voltage, you have reached the frequency, but you have energized the breaker without synchronization. In this synchronization, we match voltage and the frequency, and also the phase angle. So, if the grid supply is coming at a displacement of 180-degree and without synchronization, you have charged the breaker, then huge current will flow through that. And since the breaker is charged, the generator is running. If at that time the breaker will trip, it will produce a huge arc and it can damage the breaker. So, even the overcurrent is reached, still it will not satisfy the condition GT breaker open during accidental energization, and it will not trip the breaker for the safety of the breaker. But at that time, huge current will be drawn. Thank you. If you have any queries regarding dead machine protection, you can ask me in the comment box. I will definitely reply to you. Please like, share, and subscribe. Please support by sharing it to your friends. Thank you. Take care.